Thank you. So yeah, I'm Gossi. I work for Clark, and today I want to talk about architecture, and in particular, how we can marry our code with the businesses that we support with that, and how to scale it up. All right. So the way I see architecture is a bit like this treasure map here. So as an architect, you explored the island, you found the treasure, and now you need to make a path so for others to find this. And sometimes this is like an individual role, but more and more this is like becoming a skill in each and one of us. And so for architects, we would draw the map, and engineers need the skill to be able to understand, read it, and follow the path. Now, also what we learned is that engineers are really good at taking shortcuts. However, what we know as an architect is everything on that island tries to kill you if you leave the path. So we need to ensure that engineers can walk safely, and that's the topic of the theme of this talk. But let me start with a quiz. Now, let's imagine you're new to a company. They hand you over the code base and say, yeah, check it out and get yourself comfortable with what you see. And now you check it out, and then you ask yourself, what product is this? Could you guess from the folders or from directories? I bet not. But I got more of those. Does this help? Okay, I got the third one, but now you need to nail it. This one. So yeah, this is obviously the default directory structure for Ember. And not only Ember, but also other frameworks come with default directory structures. And why are like that? Why they have this? And the first thing is that it's good for onboarding the frameworks to explain the technical aspects that are the citizens of these frameworks. And it's also good to start your hobby project or weekend project. But if you have hundreds of components in one folder, it gets really messy, and it's hardly scalable beyond that. So let's meet our business end first, and then see how we can scale it up. So what we see in our businesses or in the code bases to that is we have these technical objects like components, services, and routes, and we also have these domain objects like those that make the business, the product is like contract, an appointment, risk audit, a saloon, or a calendar, stuff like that. So, but the technical objects are not aspects of our products, but the domain objects are. However, these technical objects have a very strong magnet and draws engineers towards them rather than the domain objects. So the domain objects, however, are the reasons of existence for the technical objects that we use to implement them. It's like, weird. So why is it so hard that we don't do domain-driven development? Well, obviously it's hard, but some of the reasons we observed here is, for some, it's education. Like in university, we learn stuff as data structures, algorithm, design patterns, performances, and a lot of technical things. And in Germany, I often hear the saying, it's like, somebody freshly graduated starting their first job is like, oh, you studied computer science. Nice. Now the only thing left is we need to teach you programming. And it's funny, but also truth. So why? Well, there's some missing courses. I would say linguistic course apparently is really important because we do have a very technical tendency to a very technical, cruddy sort of vocabulary. But this is not what the businesses are speaking. This comes with the domain-driven design practices that are also often missing in education. Second reason is that we design development workflows towards these technical aspects because we know them. And we do like visibility in our code that represents our domain. So that means no feedback from non-tech people, and also no reward for engineers to give because we don't see what they're doing. That's a bit of pity. So I thought myself, can I actually redesign this workflow a little and put the business into it? And the first step towards to us is that we need to identify the technical aspects that encode the business logic. And this comes in queries and commands. Now, queries is everything that is a read operation. We may ask a questions about the system that return us facts that we can then display in the UIs. And for a lot of things, this means controlling access, and I've found a lot of words for that. And then on the other side, we have commands, anything write operation that is like in the mental model of fire and forget. And they should like cause side effects to a system. They alter the state of the system. And you should use either one of them, but a function should not be both of this together. And this is known as the command and query separation. Now let's some examples of where we find this in our code bases. Now, for one, here's a helper that says, if this is a feature flag of Pro Plus, then we do have a special feature here. And this is the same in component, just a bit more verbose code. Now the problem is here, what is the name of the feature? Like we cannot like communicate to like PMs or designers about this because what? Same if another engineer joins later and wasn't part of the feature creation here, they missed the conversation. So they're not in context. And we have no chance of unit testing this. And this is like business critical conditions that we have here. Now for queries also we have data fetching, like communication to the APIs, and the important part is the endpoint itself, the parameters, and the payload structure. For commands, on the front end, we usually refer to them as actions. Now we see them, for example, here, onClick does onClick. I think we see this in a lot of code bases, but it's pretty, doesn't convey a good meaning of what this code is doing. So it's a bit of guessing. And then also we see this a lot in services, like the classical CRUD things or methods that we see there. Speaking about services, it's quite an overloaded term. And I basically continue what Kevin said. So we see infrastructure services. Those things are like your API client, like Warp Drive, Apollo, or your custom thing, or some messaging infrastructure. We also know application service, like things that contain application state, like your session, or like features or A/B testing. And they may even use infrastructure services. And then also domain service, like I showed you before, the user service that contains methods to create, delete, and update, and so forth. And sometimes these domain services, they live in our code base. They consume memory because they are instantiated right from the get-go, and then they are never used. So it's a lot of memory wasted. So we actually do host a lot of business logic in component service routes, controllers, models, and so forth, merely to use MSDI system, so we have access to these application and infrastructure services. So actually, we created a strong coupling between our business logic and MSDI system. So I thought myself, what is actually the correct statement? Is it A, we make a framework a dependency of our business? Or is it B, that our business drives the implementation within a framework? No, for me, it's definitely camp B, but the code examples I showed you fall into camp A. And that's like where I thought, can we actually redesign our development workflow? And I'm going to use the rideshare example for this. So in Emberfist Rome, Clemens and Mike already gave a talk about this, so I'm going to continue where they left. And also another talk here is by Scott Blashin about domain modeling made functional. And one of the ideas in this talk, amongst many others, is the idea to have one page that describes your whole domain and everybody knows what's going on. I think that's quite cool to have. So can we get there? So on the left, you see the state chart from Clemens and Mike. No worries, I go over that. And from that, I extracted already a user and the write interface and the write states. And now we bring in all of the actions. So the way it works is, rideshare is an Uber clone sort of thingy. I forgot to mention that. So we request a ride. This might be accepted. Then the drive starts. We arrive. Then it's paid. And we can cancel this at certain states in between. Now, these verbs here, actually, they told the story of the product, right? And not every time everybody is allowed to accept the request. Only drivers are allowed to. So that's why we also have guards or abilities right here to control that. And we also may have questions about the system, such as, hey, is this the driver for that ride? Or can you calculate me the travel distance of this ride so we know the kilometers and can display it in the UI? And this is the idea to implement this right now. So this is the final goal where we want to land at. And the goal for this is actually to write the right details page and to focus on the task-based UI. So can we do accept, can we do pay, and so forth. And the idea here is that we have domain code in plain TypeScript, free of any framework, and then we integrate it with Ember in the second effort. And what we have given for this is we have a user as part of the session service, and our API service is the API client. So one application service and one infrastructure service given. Okay, let's first start with the actions, and I want to cover like 3 scenarios. I hope I can cover what most of you have in your code bases. So the first one is we have a bidirectional API, some socket thing. We use a state chart. We use event-driven architecture on the backend and CQRS and event sourcing. Second scenario is we have a unidirectional API. We use a state chart and CRUD. And the third one is the same as the second, but without the state chart. So implementing the first scenario, the action, we want to accept the write. So it's fire and forget, and this is also our benchmark. Because what we have in the accept function is we are given the API client, we're given the user and the write, and then we fire a backend request. And that's the whole thing. But like to explain what I think is happening, I may get an example here. So at first is a setup of this. So we create a resource that will encapsulate all communication to the backend. We will have a state chart for the deterministic application behavior. We subscribe to the message broker, hey, give me all the events that are happening on this write. And then we also fetch the write itself. This will be stored in a track property on the resource itself, so whenever we update, it's also reflected on the UI. All right, so now let's run the action here. So we call accept. This will make the post request to the backend. It will process it over there. It will publish an event to the message broker. Since we subscribed to that earlier, we get this back into the resource. The resource saying, thank you, cool. I push it into the state chart, which will move the state. As of that, we update the track property and the resource, which gets updated into the UI. Now, that is actually, for me, the most elegant example because we write the least amount of code on the front end. Let's have the backend people do that, the rest of it. But for the second scenario, we actually do need to play a little backend here. So we use the same code, but now we need to also accept the state chart here, because we fire the request to the backend, we perhaps have some validation happening, and then in the end, we manually push that into the state chart from the action within. Now, same sequence diagram as before, but since we have no message broker, there's no subscription to the backend for receiving events. So what happens when the event is the accept function is called? We make a post request to the backend, we get the response back, we do manually put this into the state chart, so we have the statement forward as of the business rules, and then we update the write and the resource, which is tracked, so we update the resource, which is tracked, and then updates to UI, and then we give back the control to the callee. All right. Third scenario is we start from the first one, and this time we do evaluate the response again, and here we update the state of the write itself. But this is not very fault tolerant because we need to require it to be any sort of tracked, so it will update on the UI. And if you pass in something not tracked, then I promise you a lot of fun during debugging. But it might be a good alternative if you have a very slim way of doing that. All right, that covers actions. Now let's go forward with abilities that when you want to use to control the control flow of the page. Now, here we have a function that checks if we can accept this write, and we can do when the write is in state requested and the user is a driver. Now, it follows actually the idea of Uncle Bob to have single exit functions. We are only interested when we actually can do accept, and not interested in when we cannot do this. For readability, use positive statements. And here I also put like code annotations to explain like tricky code fragments, sort of. And this will become important later, so I will reveal it then. All right, now we have plain TypeScript functions. They encode the business logic. They're quite tiny, nice. So now we need to integrate them with Ember to be able to use them from the template. So basically, this is what we want to do. We have the can accept ability on the top left. We require a write and the user to be passed in. And then some miracle appears, and then we have the user dropped, and we only need to pass in the write on the template side. And the same thing on the action on the right. We would need an API client here as well for the infrastructure service, and we also drop that. So let's see what this miracle is about. So to do that, I have an ability function from Ember ability package to do that. What this thing is doing is we have an ability that takes a factory function and returns us the new function that we want to use in the template. And by that, dropping parameters. So we get the owner, so we have access to infrastructure and application services, where we get the user from the session, and then we can drop the parameters. Now, the owner in Ember is quite powerful, and we are in a situation where we actually only need to read from the owner, not mutate it. So wouldn't it be nicer if we can just get the services from the owner? And if we destructure it, then we actually can move it right into the function signature. Now, this is syntactic sugar over the owner. And this is why this is available as Ember Suite owner. So you can have it as well. And now we have a can accept ability, which we can use in the template. So we have a little bridge between Ember and plain TypeScript. And the same thing goes for actions as well. This time it's action from Ember command. It has exactly the same signature on how you want to use it. And then the result here is the same. We get an accept action back, and we can use it from the template. Maybe to note is that we need to put the braces around. That's part of the Ember helpless infrastructure, so nothing we can do about it. All right, now what we have? We have domain code, which is apparently really tiny. The function will like 3, 5, 6, 7 lines. That's okay. But we will have many of these. I'm not speaking like 10, 30, I'm speaking like 100 plus, 200 plus, depending on how complex your product is. We can easily unit test it because we can put all of the things into it because they require it as parameters. And since it's plain TypeScript, we can integrate it into many other systems. May it be Ember, may it be state charts, may it be a library that you also use. But it's so hard to code it like that. It's still hard to wrap your mind around this, like organize the code the way I showed you. And you might also say, hey, Gossy, that's a very, very naive design. And I would agree, because that's a mistake we made. We were hopeful that this will be picked up, and it wasn't really the case. So what was missing here is that we need to give visibility to what's happening here. And if we have visibility, then we also have a way to reward engineers for following this idea. So this is the way how we want to safely guard the engineers on the island around. So we need to implement that. So let's finish the design workflow around that. So I thought maybe we can have a matching number that says, hey, if this number, like similar to code coverage, like if this number is high, that means engineers are following the architecture design that we put up here. But spoiler alert, no, I didn't find one. So what else? Actually, Mother Nature came to rescue. So what biologists are doing here is, if they look at a certain biome or certain area of land, they look for indicator species, like animals or plants that live there only if the living condition is good enough for them. So it's like, maybe we can use an indicator then. And the indicator should be that we can bridge between engineers and non-tech people, so they have a conversation based on the business, not on the technical implementation. And the solution for that is plain that simple, is use TypeDocker, use an API generator. So I did run this in the code. And this is type doc. It generates the right interface. And as an engineer would say, cool, nice, done, job done. We can send this off to PMs, and then they can look around and see what we have. But no, not really. So if you look at the navigation on the left, so we have some right-check core modules, domain objects, right, and then now these fancy vocabulary enumerations, interfaces, type aliases, variables, and functions that are also very cluttered. And this is not good vocabulary to speak with like a non-tech person about your product. Luckily, TypeDoc allows us to fix that. So there's a little configuration we need to do. First, we need to organize our domain aspects. We can use the group and the module tags. Second is we can give our meaning to our code with the add category. And then we have add source with the plugin mentioned below, and then it can embed the source code of the thing we're documenting into the docs. And then a little bit of configuration to TypeDoc to respect what we want, and ta-da! This is where we can end up. Now let me explain. First of all, we have organized or restructured the navigation on the left. Now we have domain objects, we have our right, we have abilities, so what can you do here? We have the actions, like what's actually happening then, and then we have the domain itself, so you can inspect them, and then we also have the questions of the system organized. Now, and also on the can accept function in the middle here, you see that the source code is embedded. And now think about this, you sent this off to a PM, and now we made this readable to non-tech people. Like the code is for us, and the comments are for PMs. So imagine this, you are implementing a new feature, the PMs thought about the new conditions, and then you come here and say, oh, it's conflicting. It doesn't really work with what we have. And then you can have a conversation about this, and you can send this off like, ah, yeah, really, okay, we need to like rearrange things here or correct it to what we want to have. So you're not like overriding your existing business logic by accident. And also, this also gives visibility to what's available in your domain. And if the things pop up on the left, that's the indicator we're looking for. So if it pops up, then engineers can follow the design we look for. So what's the benefit of this? Obviously, we make the complexity visible that lives in our products, and usually that's super complex. We did this on a code base that's in production for 2 years now, and since then, we have seen a significant reduction in bugs. I think we have one technical escape, but for business logic, we were pretty safe on this one because we had everything tested. Really, really cool. Also, what we see is that after we followed this, that the feature delivery actually improved by a factor of 2 to 3. Now that surprised all of us in the team, including us engineers. And contrary to what you might think is that it also increased the developer velocity. So because we can use things that were already there. So we had fixtures for testing this in TypeScript, but then we used the fixtures also in the components to test them. And you can do like business logic Lego. So what do I mean by that? So maybe you have a good and really nice feature, but it's very borrowed in the UI. So users need to click a couple of things to actually access it. And your PM's like, oh, maybe we need to give this a bit more prominent location. So only what they need to give you is the UI and where the places that they need to have it. And it's like, okay, I only need to build the UI because the business logic is there and the conditions already, so you can attach it to the new UIs. All right, so now that we know actually what we have that encodes business logic, we need to organize the code around it and scale it up if we grow. So a naive approach would be, okay, use add-ons, use engines, move code into them. But that gives you a false sense of scalability. But I have a better example to explain this to you. Now, imagine a zoo. Now, the technical goal here is to keep animals safe from visitors. So a technician may come in and say, okay, I build a compound, one for animals and one for visitors. Job done. Mission accomplished. Well, until somebody with domain knowledge comes in and is like, who the heck put carnivores and herbivores into the same compound? That didn't work out because actually you did not accomplish your mission. You created a short-term attraction. So it's not really long-term sustainable solution. We need something else. So I gave a talk about this before, how to organize this on the zoo, because there's a lot of decision you might come across. If you're interested, go check this out. I have the short version for today. So, first thing is understanding the domain, understanding the product you're working with, or the compartment. So the first one is the core subdomain. This is what makes your business unique, what maybe let it stand out against the competitors. Second is the supporting subdomain, so any ancillary parts that support your core domain. And then generic subdomain is everything that you basically need to keep it running. I think for most of us, this is some authentication user management, but we don't make a business with that. We use it to make our products work. Now, and these subdomains are really, really good to help us manage the code at scale and to put it into manageable pieces. Now, I think it's time to solve the puzzle from the beginning. So let's take the Amber default directory structure, and this is what I created out of that. Now it's a bit more verbose, and actually that's from a Amber app running in production. So what do we have here? On the app root folder, we only see application assets and routes. This is for technical reasons, but the main thing lives in domain folder. So the business itself is like arts, assistant, choreography, courses, exercises, games, and so on. Moves, skills, and training. And it's supported by audio and Spotify. And the rest is technical parts. So alone from this, you can have a better guess of what this is doing rather than what you see on the left. And apparently, that's a training website for the best sport in the world, for unicycling. So it contains a lot of training materials that I, as a coach, document over there and make it available to other coaches. Now, the code itself is open source. You can see it here. But I give you a little, like the little color phone to jumpstart you. Now, the first thing you see in these domain directories is that each of these folders has an index.js file, and that's the gateway into them. So they only export what we need in the outside world, and not more. Routes are also exported with this, a bit of technical reasons. It feels like a V1 add-on, and then we use these routes in the routes folder. And I went a bit of experimental here with Emma Polaris routing. There's also Emma route template and Emma Polaris service. And the latter allows me to have services in the local folder of the domain itself, so not splattered in the root services directory. So what's inside the subdomain to a bit more clarify? We see the domain objects, we see actions, abilities, and questions, and then the Ember parts, routes, components, services, resources, whatever. And the important thing is that we have this public API gateway to make only things accessible to the outside world that need to go there. Now, if we look into these directory structures again and put some architecture terms to it, on the left we have a monolith, on the right we have a modular monolith. And the latter can come in different flavors. So the directory itself, or the domain, I already showed you, but there's also a monorepo or polyrepo version of it. And basically this helps us to scale up, to find the next step for your products. You might start as a monolith in a default Ember app, and then you can go into directory, into monorepo, into polyrepo, or from a directory to monorepo, and so forth, like whatever is like applicable to you. And I put microphone in here just for completeness. But let's start with the polyrepo, because polyrepo here is our benchmark. So we might have our own repository for only the training part. Oh, you don't see the colors that they have like different color coding on the right. To note that some are internal packages and some are public packages. So the pro thing, or like the benefits of this approach, is that we have the repository to use, that we can use the physical boundaries of the repository, and everything that we want to make public, this is the thing we publish to the registry. So we need that for sure, and we need to run the publish update dance here. But luckily, we have a really cool tool called Release Plan that lets you release literally from anywhere. And I heard there are stickers somewhere. the team who built this is also around, so please give them a thank you hug later on. And then we have other tools like Renovate or Dependabot that we can use to actually automate some of the updates in the repositories that need to consume those. So what we can do or use the repository, the polyrepo approach for is that we can have one M engine in there that gives us the isolation context to mimic the subdomain boundaries here, and also single entry mount point that we can use in our host apps. Next up is the monorepo. So we have like a structured folder, and we have some of these maybe packages that are for one subdomain. So the benefits of here is that we don't need to do the publish update dance, and we have faster development time, but we need to mimic the boundaries that the polyrepo would give us. And that's something, that's our situation, and we forget these this linting against these boundaries. So we have some illegal dependencies made up, so we don't have the best way to isolate our subdomains and move them into a polyrepo. So that's something you need to take care of and put into your tooling. But also it serves a little bit as a breeding ground. So from one directory and multiple packages, you can grow up and then maybe move into a polyrepo once it's good enough. So microphone, just for completeness. So for on all of the monolith would be a single deployment unit based on the host app. And in a microphone world, we would have this as independently deployable units by subdomain. M-engines would be the choice here, but I heard that might not longer be up to date. I think there's something brewing from the Broider team, but they change, every PR changes what they do, sort of. So this is currently not possible, but I want to just mention it for completeness. So maybe at some points we have something to do that. So what you want to take away from this is focus on your domain. It's your product, it's your business, that brings the money in, keeps you working. So make the domain you have visible and show the complexity that lives in there to people, non-engineers, that also have an interest in that. With that, you can reward the engineers to do so, and also your domain tells you how to scale up, how to manage the individual pieces. And that's it. Thank you. Yeah.